Welcome back, students. In this video we'll be doing the last two questions of exercise 1.1. So this is given, okay, we are asked to use Euclid lemma to show that the cube of any positive integer is of the form. So first thing is, I'll say let a be any positive integer. Okay, I'll just assume my a to be any positive integer. So we're asked to show that a cube must be in the form of 9m or 9m plus 1 or 9m plus 8. It will be only in one of this form. Okay, and we'll do one thing. I'll take my b to be equal to 3. Okay, I'm taking it 3 because all of this 9, if you look carefully, are all multiples of 3. Okay, you can take it 9 if you want, but it becomes very huge. This problem, when you take b as 9, it becomes very long. Okay, so in order to reduce that, I'll just take my b to be equal to 3. Therefore, by Euclid's lemma, okay, by Euclid's division lemma, we know that a is equal to bq plus r, where r is a value less than b. It's also a value greater or equal to 0. So you take your b to be 3 cubed, that is given to us, right? So that means r should be a value less than 3, or it should be a value greater or equal to 1. So what are the possible values of r? The possible values of r is going to be just a 0, it's going to be 1, and it can be 2 only, it cannot be 3. All right, remember, don't take numbers like 2.9, 2.8, 2.5, because you must keep in mind that r is also an integer. So 2.9, 2.8, those numbers are not integers. Okay, so now when r is equal to 0 in 1, okay, so a becomes 3 cube plus 0, so that is a is equal to 3 cube. Now because we're asked to find the cube, right, so we have to take cube on both sides. Right, on both sides, what do you get? You'll get this as a cube equal to 3q, the whole thing cube. So this becomes a cube equal to 3 cube is 3q into 3q into 3q. Okay, for those of you who are still not very sure of this, so 3 into 3 is 9, 9 into 3 is 27. So 27 q into q into q gives you q3. Okay, so you can write this as 27 q cube, right? Now try to understand the question. The question is asking us that we have to show that the cube of any integer is of the form 9m. So you should take out 9 out here. So if you take 9 from here, you're left with 3q cube. Okay, so therefore you can write your a cube can be written as 9 of 3q cube. All right, it still gives you the same. You open up the bracket, 9 into 3 is 27, you'll get back the same answer. So you can write this a cube as 9k k1, where k1 is equal to 3q cube. Okay, or for some of you can just write a cube as 9m itself. Okay, if you want, you can just directly write that and write this as m equal to 3q cube. Okay, because that's what we were asked to find out, right? Now similarly, when r is equal to 1, we'll have a as 3q plus 1. You take the cube, okay, you take cube on both sides, so you get this as 3q plus 1 whole thing cube. Now use the formula of a cube plus b cube, that is a cube plus b cube. Okay, just try to remember this. a plus b, the whole thing cube, is actually equal to a cube plus b cube plus 3a square b plus 3ab square. Okay, so this is going to be 3a square is going to be 3q square into b plus 3 into 3a is 3q into 1 square. So take this out, you'll be getting this as 27q cube plus 1 plus 3 into 9 gives you 9 into 3 gives you 27q square plus 9q. Okay, all right, so you bring all these terms together, 9q cube plus 27q to the power 3 plus 9q plus 1. And what I'll do here, remember we're asked to show that it is of the form 9m or 9m plus 1 or 9m plus 8. So you see, whatever changes you can make, you can take 9 common here, right? So when you take 9 common, you're actually going to be left with 3q to the power 3. You're also going to be left with 3q to the power 2. 9q, you're going to be just left with q. Now put 1 here. Okay, so if you want, you can just replace this as 9 K2 plus 1, where K2 is equal to 3Q cube plus 3Q square plus Q. Okay? Alright. Okay, for those of you, you can also write this as m itself if you want, okay? So that will give you what you want, 9m plus 1, 9m or 9m plus 1. It does not make any difference, okay? K or m, it does not really make any changes, okay? Because either ways, K1 is still going to be an integer, right? Because when you replace the value of Q with any arbitrary integer, you're going to get an integer back. So you don't really have to worry about that, okay? So we have found out the first thing. Now, when r is equal to 2, okay, so when r is equal to 2 in A, your A becomes 3Q plus 2. So you take cube on both sides, you'll be getting this as 3Q plus 2 the whole thing cube. So this becomes A cube. So A cube plus B cube plus 3A square into B plus 3 into A B square. Okay, so this will give you 27Q cube plus 2 cube is going to be 8, 3, 9, 3, 27, 27, okay. I'll just write this as 27Q square into 2 as of now, plus I'll write this as 9, 3 into 3 is 9, 9Q into 2 square is 4. Okay, this is just for computation purpose. Now bring all the terms together. So 27Q cube, I'll bring it together. 27 into 2, you can just multiply that. They'll give you 54Q square. 9 into 4 will give you 36Q plus 8. I'm just rearranging them. Okay, so try to go back what the question is asking. Okay, so 9m, 9m plus 1 and 9m plus 8. So for some of you who have understood, you already see a pattern here. So if you take 9 common out here, you'll be left with 3Q cube plus 9 into 6Q square plus 9 into 4Q plus 8. So your A cube, this becomes 9K3 plus 8, where K3 is going to be equal to 3Q cube plus 6Q square plus 4Q. Okay, or some of you can even write this as A cube is equal to 9m plus 8. Okay, and in bracket, m is equal to 3Q cube plus 6Q square plus 4Q. Okay, so therefore we have shown that, okay, the cube of any positive integer is of the form, okay, 9m plus 1, 9m plus 8, or some of you can write this as 9k1, okay, 9k1 plus 1, or 9k2 plus, this is k2, 9k3 plus 8. Okay, so this is how you can conclude your answer. All right, so quickly moving on to the last question. Okay, so this is the question which is given to us. Solution, solution. Okay, so there are 156, 208 and 260 students in group A, B and C. Okay, group A has 156 students, group B has 208, group C has 260. Now buses are to be hired for field trip. We are asked to find the minimum number of buses to be hired if the same number of students should be accommodated in each bus. Okay, remember we are asked to find the minimum number of buses, not the maximum number of buses, the minimum number of buses. So first we have 156, we have 208 and we have 260. So between 156 is less than 208. In fact, even 156 is less than 260. So we find HCF of 156 and 208. Okay, same thing we find the HCF of 156 and 260. So why are we trying to find out the one HCF is because this HCF that we find out will indicate how many students can sit in one bus, or what is the maximum number of students that can be seated on one bus, okay, in one bus. Clear? HCF will give us that. HCF will tell us that this amount, this is the most number of students, or this is the maximum amount of students that can be seated in one particular bus. Okay, so that is, you just have to use division algorithm. I'll just try to divide the screen here. We'll try to do a step by step. 208 and 156. 156 times 1 is going to give you 156, so this is going to be 2, and this will give you 10, so it's going to be 52, and you have to divide this with 156. So this is 156 into 1. We got the remainder as 52. Now 156 becomes the dividend. Now 52. 52 into 3 is 52 into 3 actually gives you 156. Clear? So 52 into 3 gives you 0. So HCF of 156 and 208 is 52. Okay? With the least number, we'll try to find out this. Similarly, let's try to find out for this. 260 equal to 156. Now, 156 and 260. Okay, so 156 into 2 is actually a value that is 312. It's too high, so we'll go with 156 into 1. So when you do this, you'll be getting this as 10, so you'll be left with 5. So this is going to be 104. So 156 into 1 plus 104 gives you 206. Now, let's write here, go over here. 104, let's divide it with 156, okay? So 156 is the dividend and 104. So 104 into 1 will give you 104, okay? Absolutely no changes, 2 and 52. So 104 into 1 plus 52 gives you 156. Now 52 becomes the divisor and 104 becomes the dividend. So 104 equal to 52 into, in fact 52 into 2 is actually 104. So 52 into 2 plus 0. Therefore, the HCF of 156 and 260 is also 52. Clear? So we have already verified, okay, that in a bus, the maximum number of students, that can be seated is 52. Okay, but we're not asked to find the maximum number of students. We're asked to find the minimum number of buses that has to be hired. Okay, so in each bus, if 52 students can be seated, then therefore let's first find out the total number of students. Okay, so the total number is going to be 156 plus 208 plus 260. Okay, remember what are we trying to find? We're trying to find out the maximum number of students. Okay, the total number of students, which is 624. Okay, so you just look at this. 624 is the total number of students, and in one bus 52 students. In one bus only 52 students can be seated. Therefore, the minimum number of bus required, minimum number of bus to be hired. Okay, so you have 624 students, and in each bus 52 students can be seated. So you take a division of this, 52 and 624, 52 1 times 52, so 104, and 52 times 104, so you're getting it's 12. Therefore, the minimum number of buses to be hired is 12. So if you hire 12 buses, okay, in each bus 54 students can be seated. Okay, so you do this 12 into 54, so 8, 4 times 4 is 1, 5 times 2 is 10, so 6. So wait, okay, 156 plus 208 plus 620. Yeah, maybe I made a this is 52, right? So 2 times 2 is 4, 2 times 2, so this is going to be 624. So you just see, you look at this. So we need to hire 12 buses. Okay, when you hire 12 buses, in each buses 54 can be students can be seated. Okay, so in all the 12 buses 54 students are seated. Okay, so when you count them, the total number will be 624 itself. Clear? So with this we shall end the video here and end with exercise 1.1.